Namaste. Welcome to the tutorial class on virtual classes. Before starting the virtual classes, consider this figure of hierarchical classes. I is a base class which derives the two class I and K. Derived 1 and this derived 2. And these two derived classes, again it is derived, and it is what? Derived 1, 2, that is I, K, I, J and K. So in this type of situation, what we need to do? So the remedy is scope resolution operator or virtual classes. So we will discuss about the virtual classes now. Used to prevent multiple copies of the base class from being present in an object derived from those objects by declaring the base class as a virtual when it is inherited. The simple syntax is class derived virtual public base. A virtual function is a member function that is declared within a base class and redefined by the derived class. Virtual function implements the one interface multiple methods philosophy under polymorphism. The virtual function within the base class defines the form of the interface to the function. Each redefinition of the virtual function by a derived class implements its operation as it relates specifically to the derived class. That is, the redefinition creates a specific method. Virtual function. To create a virtual function, precede the function declaration in the base class with the keyword called virtue. Means, example, you have a base class which public, I have created this as virtual. Next, virtual function. Here I have a base class that which consists of a virtual function which derived 1 and derived 2, that will be overridden. When accessed normally, virtual function behave just like another type of a class member function. But virtual functions are important and capacity lies in supporting the runtime polymorphism when they are accessed via pointer. Now, how to implement a runtime polymorphism? Create a base class pointer can be used to point to an object of any class and derive from the base class. Initialize the derived object to the base class objects based upon which the derived class objects assignments to the base class pointer. C++ determines which version of the virtual function to be called, and this determination is made at the runtime. Next, the redefinition of virtual function by a derived class appears similar to the function overloading. No, the prototype for a redefined virtual function must match exactly the prototype specified in the base class. There are some restrictions when you are using virtual function. All the accepts of its prototype must be same as the base class virtual function. Virtual functions are non-static members. Virtual functions cannot be a friend. Constructor functions cannot be virtual, but destructor functions can be virtual. Note, function overloading is used to describe the virtual function redefinition by a derived class. Destruction functions can be virtual. Yes, in a large project, the destructors of the derived class was not called at all. This is where the virtual mechanism come in our rescue. By making the base class destructor virtual, both the destructor will be called in an order. Next, function overloading. A function overloading is a process in which member function that is declared within a base class and redefined by the derived class to be implement the one interface multi-method philosophy under polymorphism. Calling the virtual function through a base class reference. Since the reference is an implicit pointer, it can be used to access the virtual function. When a virtual function is called through a base class reference, the version of the function executed is to determine by the object being referred to at the time of the call. The virtual attributes is inherited. When the virtual function is inherited, its virtual nature is also inherited. Example, virtual function which is derived for derived 1 and it is derived for derived 2 and its virtual nature is derived at derived 1 and derived 2, that is overridden. Virtual functions are hierarchical. Virtual functions are also hierarchical in nature. This means that when a derived class fails to override a virtual function, then the first redefinition found in the reserved order of the derivation is used. Virtual functions are hierarchical. Yeah, base class, derived 1, derived 2. Virtual function overridden, the first redefinition is done, but it cannot be non-overrides in the derived 2. Next, virtual functions are hierarchical. Yes, first definition should be done, which is virtual function derived. In derived 1 it is overrid, whereas in the derived 2 it is not overrid. Next, pure virtual functions. A pure virtual function is a virtual function that has no definition within the base class. To declare a pure virtual function, virtual read type, that is the function type, function name and the parameter list, and it is equal to 0. When a pure virtual function is made pure, any derived class must provide its definition. If the derived class fails to override the pure virtual function, a compile time error will be result. Note, when a virtual function is declared as pure, then all the derived class must be overridden. Abstract class. A class that contains at least one pure virtual function, then it is said to be abstract class. No objects of an abstract class can be created. Abstract class consists of an incomplete type that is used as a foundation for derived classes. Using virtual functions, when can achieve the most powerful and flexible way to implement the one interface multi-methods, we can create a class hierarchy that moves from general to specific, from base to derived. Using virtual function, when we can define all the common features and interface in the base class. Specific actions can be implemented only by the derived class. We can add new classes easily. Earlier versus late binding. Earlier binding refers to the events that occurred at the compile time. Earlier binding occurs when all the information need to be called to a function is known as compile time. Example, function call, overloaded functions calls, and overloaded operators. Late binding refers to the function calls that are not resolved until the runtime. Late binding can be made for somewhat slower execution time. Example, virtual functions. Thank you.